Hey there, guys. I'm really sorry I had to be gone again. I really hate this. But we thought Nola was going to get better today and it seemed like her fever was going down, and then it came back up tonight. And my wife's already missed the last 2 days of work, so I needed to take my turn again. Um, so we're going to be talking about polynomial long division today, and just words of the wise. This tends to be a pretty tough, um, section topic. So yeah, I'm sorry I can't be there to ask your questions as they come up, but really try to think about what my students today asked me and try to hit all those points as I'm going through the video. And it is nice because you'll be able to go back and listen to what I say again when you need to. So a little bit of advantage, but to that. So just some pictures that my wife did send me today is I think these were yesterday. Nola, when her fever was really high yesterday, she was having some struggles. So here she was. My wife sent me with this one. She said that Nola's being a wreck right now. So I think here she is kind of like leaning against the door, just kind of pouting about something. It was kind of funny to see that. And then here's another one where she was just kind of crashed out on the couch with her teddy and her was our glowworm there and reading a graphic novel. So just made a little nest for herself on the couch. So I'll be taking care of her, and hopefully she gets to go to school one day this week on Friday. So I'll be back to teach you something called synthetic division, which I promise you guys will like much more than long division. It's much easier, but we have to do long division because it works all the time, and synthetic division only works sometimes. So we got to know like both cases. Um, but what I want you guys to do is think back to what you know about just long division, from when you learned it in fourth grade or whatever. Um, Going back and thinking about that really, really will help you understand how to do long division with polynomials. And you ask yourself a lot of the same questions, and then this idea that it's a process that repeats or iterates is a word for that. It has iterations, where you do a couple steps and then you need to repeat those same steps over and over again. Um, so if we think about how we do, just regular old long division, that first question we used to be asking ourselves is, we look at our number here that we're dividing by, and we say, we look at the first digit of the number we're trying to divide, and so, does 5 go into 6? And, so it does, and so we're going to say, well, how many times does 5 go into 6? And so we say 1, and so we put that, what are we going to multiply 5 by to get to as close to 6 as possible, really is a question that we should be asking ourselves here. So 5 times 1, so well, then what is 5 times 1? It's 5. And then we're supposed to subtract, 6 minus 5 is 1. So I bring that 1 down, and then I bring the next digit down, so now I'm at 14. And then I go back and kind of repeat that question, right? So how many times does 5 go into 14? Or what do I multiply 5 by to get as close to 14 as possible? So kind of listen to how I'm phrasing that. So, and then that's, 2, and then 2, and so 2 times 5 is 10. And then we subtract. And then 14 minus 10 is 4, and then bring down the next digit, which is 47. So then again, going back to that question, what do we multiply 5 by to get as close to 47 as possible? And that would be 9. And then 5 times 9 is 45. And then we subtract. And then 47 minus 45 is 2. Sorry. And then we bring down that last digit. That's 5. So what do we multiply 5 by to get as close to 25 as possible, which would be 5. What is 5 times 25? Which, of course, is 25. And as we go to subtract, we get 0. So we got our remainder of 0 there. So remind you what that word is. So then our answer is, 6,475 divided by 5 is, what's on top of the bar there. So 1,295 with no remainder. So what that means is that 5 divides into 6,475 evenly. Okay. And then, so looking at the next problem, what's 132 divided by 5? So we look at that first digit and say, what can I multiply 5 by to get to 1? And there isn't anything, so then we have to bring in the next digit. And so, what can I multiply 5 by to get as close to 13 as possible? And that would be 2. And then what is 2 times 5? Which is 10. And then we subtract, and then bring down the next, or that 3, 13 minus 10 is 3, and then bring down the next digit, which is 2, and then say, what do I multiply 5 by to get as close to 32 as possible, which would be 6, and that's 6 times 5 is 30, subtract, we get 2. Now, there's nothing else to bring down. I can't multiply 5 by anything to go into 2, so 2 is the remainder, and we're not going to write any decimals here because we cannot do that. So what we do is we take that remainder and we write it over the divisor, and the number dividing by, which would be 5. So 26 and 2/5. So we take that remainder and write it as a fraction of the divisor. So just kind of think about that process, noticing how we did certain questions, answer certain questions, then we get to here, and we start those same questions over, and then it gets to here, start those same questions over, gets to here, start those same questions over, gets to here. So just that iteration idea that we do the same thing over and over and over. So 6,000. So way back here is, what can I multiply by 5 by to get as close to 6 as possible? So really, again, what I can multiply the divisor by to get as close to that first digit of the dividend is possible. What do I need to multiply 5 by to get as close to 6 as possible? 1. So then we said, well, what is 1 times 5? It's 5. So we take that, we actually do that multiplication that we said we would. Step was to subtract. When we did it in this first problem, there's the second example, so the 26 and 2/5. So you hear the way I said that, 26 and 2/5. Well, in math, the word and means add. We just don't write that. It's 26 plus 2/5. We just stopped writing that a long time ago. We still say it though, and when we read the problems, a little bit of vocab here. So just again reminding you that we're going to take remainders and we're going to treat them as fractions of the divisor. A little bit of vocab here. I think I've already said divisor a couple times. So that number that we're dividing by is called the divisor. The number that we're dividing, so the thing being divided, is called the dividend. And then the answer to a division problem is called the quotient. So, and then just kind of saying what I said here. If there is no remainder, so like on that first problem that we did, that means that A divides B evenly, so our 5 divided 475 evenly, that 1295 times, or that A times 5 times 1295 equals B. Another way to say this, which is going to be a theorem we're going to talk about later, so you don't necessarily write this down, is that if there's no remainder, what that means is that A is a factor of B. And we have something called the remainder theorem, which we'll discuss it in a different class period next week sometime, I think. So, but just a kind of a little preview there. So, what was then to do? And then here is more complex this, so we're not going to exemplify that with. So this is going to be our first long division problem for polynomials. What I had my students do yesterday, if you kind of read my notes here, was watch me first, listen to me first, really try to want you guys to listen to what I'm saying, watch what I'm doing, and then go back and copy it down later. So you just really try to absorb it first, and so you're not being distracted by writing, and then you can copy it down what I said later. So here are the steps over here on the side. So this is kind of the way the textbook writes them. You're going to hear me use different words, a different way of thinking as I go through those same steps. So, which is the way I've really come to, as I've taught this over years, seen students do best with it. So the way I'm going to phrase things is really going to be try to help you guys do it the easiest way possible. So, so first off, we need to rewrite the problem as like a long division problem. So I'm going to take that x plus 3. I don't want red. And so there's my divisor, and then my dividend x cubed minus 2x squared minus 22x minus 21. And so, our first question, we're going to do something similar here. Like we're only going to look at this x cubed, that first place, that first term of the dividend. In the same way, we're only going to look at the first term of the divisor. So you really got to understand that you're focusing purely on the x there, not the x plus 3 right now, as far as like what do I need to multiply by. So the question I'm going to ask myself is, what do I need to multiply x by to get x cubed? So the answer to that question being x squared, right? X times x squared would be x cubed. And so if we think back to what we did with the long division, and so as I do this multiplication, now the x plus 3 is what's being multiplied. So you have to make sure you distribute that x squared here to the x. So that would be x cubed. And then x squared times 3 would be 3x squared, so positive 3x squared. So make sure you distribute there. That's really important. I wouldn't suggest you guys write those arcs like I did. And then now, as we just did subtraction of polynomials, you guys had that test over, was adding and subtracting and multiplying polynomials was part of it. We just need to understand that when we put a minus sign there, we're actually visually going to trick ourselves a lot if we just put a minus sign there, and it kind of forces, okay, what's x cubed minus x squared? People's tendency is not to do this, to say negative 2x squared minus 3x squared, which is what you're supposed to do. That's not how people read that. They just tend to get a little lazy with their eyes and then look straight down. And so then it says negative 2x squared plus 3x squared, which is not the math we're supposed to do. We're supposed to do negative 2x squared minus 3x squared. And so what I would suggest you do, instead of subtracting, we're going to add the opposite. It's the same thing. If I say what's 7 minus 4, well, it's the same thing as adding the opposite of 4. So I think this tends to go a lot better for students is if you focus on, I'm going to change my signs, I'm going to make them the opposite of what they are. So minus x cubed and then minus 3x squared. And then all we have to do is read straight down. X cubed minus x cubed, negative 2 minus 3, that you're going to be a lot more successful. So these first two will always cancel. They should always be exactly the same. And these next two should always be similar in the fact that they're both x squareds. So they should have the same exponent. And then, so negative 2 minus 3 would be negative 5x squared. And then I bring down the next term. And then we start that process over again. So here's that iteration. Okay. And so I look here. And I compare it to the x. And I say, well, what do I need to multiply x by to get negative 5x squared? So that would be negative 5x. So I write that up on the top of the bar. And then just like last time, I'm going to distribute that negative 5x here and here. So that's going to be negative 5x squared. Let me get rid of that. And then negative 5x times 3 would be negative 15x. And so what I want to notice is that these two are exactly the same. And then these two are similar, and they're both x's. So they're like terms, essentially. And then we want to subtract. So what we're going to do instead, though, is add the opposite. So this is a negative 5x, so I'm going to change that to a positive 5x. This is a negative 15, so I'm going to change that to a positive 15. A student in class asked me today, just noticing that these two were both minuses and that these two were both pluses if they had to be the same sign, and they certainly don't. I'm just changing them from what they are. So, and now I'm going to add down. So negative 5x plus 5x would cancel, and then negative 22x, or sorry, x squareds, negative 22x plus 15x would be negatives. Would be negative 7x, and then I bring down the next term, which is minus 21. And then I start that process over again. So I'll look at the first term here, compare it to the first term here, and then say, what do I need to multiply x by to get negative 7x, which would be negative 7. So minus 7 there. And I'm going to distribute that minus 7 here and here. So that's going to be negative 7x minus 21. kind of check, see how things are going. I want to make sure that these two are exactly the same, and then these two are similar, so it turns out they're exactly the same, but they are similar in the fact that they're both just numbers, there's no x's or anything like that. Again, that idea that they need to be like terms. And then I'm supposed to subtract, so I'm going to change the sign. So I had a negative 7x, so we have a positive 7x. I have a negative 21, so we have a positive 21. And then I'm going to add down. They cancel, so it gives me a 0. So that tells me that this divides in evenly. What it really is telling me is that x plus 3 must be a factor of x cubed minus 2x squared minus 22x minus 21. So our quotient is just that x squared minus 5x minus 7. So there's our final answer. So this is what you're going to need to copy down. A couple things, as I kind of hit the highlights. Notice how I'm always using a different color when I change my signs. I suggest that those of you that keep pens and stuff with you, you might want to try doing that using a different color, because you really are going to need to visually confirm with yourself that you have done this, so that you can do that subtraction correctly. So again, the idea is that we're changing the signs, we're adding the opposite. That really will, I think, make things easier on you guys. Make sure you're only looking at that first term and asking yourself, what do I need to multiply x by to get x cubed? And that's what goes up here. And you've got to distribute. And once you learn the process, it's it's the distribution errors, it's the changing sign errors, and then just little arithmetic errors. Usually students get the process down. It's just then being careless, moving too fast. These are not problems you can move fast through. But we're going to practice a couple. Hopefully kind of get the rhythm of it. Just again, please kind of keep listening to the way I'm talking and the little things I'm doing to try to help you guys be successful here. So, okay, let's try that again. All right, so last time we didn't have remainder. Problems like this. So this problem has a little bit of a warning. So if we have any missing terms, so if there's a missing term, we need to write a 0 to keep its place. So what this is really, if you think about a number like 3,704, why do we bother writing a 0 there? This is, 4 ones, and that's our tens place, and that's our, hundreds place, and that's our thousands place. Each of those digits stands for something. We kind of stop thinking about that after we learn it. Well, it's the same thing here with these expressions, that each of those terms represents a certain degree. Here's, we have 1x to the fourth, we have 2x cubes, we have negative 7x squared. But then where are x's? Well, we must not have any x's. So we don't write it. Why would we bother writing 0 x's? What's the point? Well, what it comes down to is with a problem like this, not writing that 0 really causes problems. And so what you're going to hear me refer to this is gaps. We got to fill gaps. So it's not something that's mathematically necessary to do this, but it will really, really, really will help you do the problem more successfully if you fill your gaps in. So we check over the problem first, make sure that it goes down, 4, 3, 2, 1x, and then no x's all the way down. And I'll keep talking to you guys about that. So x plus 2, and then x to the fourth plus 2x cubed minus 7x squared plus 0 x's or minus 0 x's, really doesn't matter if you have plus or minus, since it's just a 0. But don't just write 0, make sure you write 0x. If it had been the x squared term that was missing, we would write 0x squared. So make sure you write 0x, not just 0. And don't put just a 1x, because 1x and 0x are the same thing. So I've had seen students where they fill in a gap with 1x, and that's not good. You want to fill it with 0 x's. There are no x's in this problem, so we need to make sure you write that. And so what we're going to do is start that process by looking at the first term of our divisor and the first term of our dividend and say, what do I need to multiply x by to get x to the fourth? And that would be x cubed. And then we take that and we distribute. So we ask ourselves, what are we going to multiply by? And then we multiply by that. And so x cubed times x is x to the fourth. X cubed times 2 is 2x cubed. And then we check to make sure these are exactly the same, and then these need to be like terms, so they're both x cubes, and they are, so we know we can move forward. And then I want to subtract, but to do that I'm going to add the opposite, so I'm going to change my signs. Again, you need to make sure you have some sort of visual indication that you have changed those signs. I wouldn't erase and then write the new one in there for you. I would just, that's why I like to use a different color to overwrite it. But really you need to make sure you know you've changed those signs. So this problem has a little catch to it. So the first two terms cancel, the x-force cancel, and then the 2x cubed minus 2x cubed gives me 0x cubes. And as I go to bring down that next term, so what we can do here, because this is a 0, that first term is a 0, we can actually skip that step. And so this won't happen too often, but basically what I'm going to do is I'm going to ignore this because it's a 0 at the front, not if it was a 0 at like the second term, and then I'm going to bring down another term. And even though I know it's a 0 that's bring down, it's because this was the first term 0 that I'm going to ignore that. And so I'm going to kind of go back again and say, what's my x need to be multiplied by to be 7x squared? And that would be negative 7x. And I'm going to distribute that. So negative 7x times x would be negative 7x squared, and negative 7x times 2 would be negative 14x. And then we check to make sure things are on the right track. So these are both squares, these are both x's, and that means I can move forward. I need to subtract, so I'm going to add the opposite. So this is a minus, so I'm going to turn it into a plus. This is a minus, so I'm going to turn it into a plus. And then I can add down. So these two cancel. It's like x squareds cancel, then 0x plus 14x is 14x. And then the negative 14 drops down. So right here we see why that 0x helped us, because if we'd done what we had, if we hadn't put that in there, the 14 would have been here, it would have dropped down, and we would have had this 14x and then a 14, and those would not have combined. And so it would have messed us up visually. There is a way to do it mathematically, but I think just stick to this and you'll be better off of filling in those gaps. So, and then first term to first term. So what do I need to multiply x by to get 14x, which would be positive 14. So make sure you write plus 14 up there, not just 14. And then you distribute, gives you 14x. 14 times 2 is 28, positive 28. So we have x's to compare, and we have numbers or constants to compare. So everything's working out. Change my sign to a negative 14, change my sign to a negative 28, and then we add down. 14x is canceled, negative 14 minus 28 is negative 42. And we should start that process over again, right? But I don't have anything to bring down. And if we go back and check, like, what can I multiply x by to get 42? Well, there isn't anything I can multiply x by to get negative 42. And so there's a couple things telling us that that's the end of the problem, that the negative 42 is the remainder. The main thing you want to focus on is that this is the last time we brought it down, the last term we could bring down. So that meant this was the last line of our work. So what we have here would be our divisor. X plus 2 goes into x to the fourth plus 2x cubed minus 7x squared minus 14x. It goes in x cubed minus 7x plus 14. And then you are always going to put a plus there. And you take your remainder, negative 42. Even though it's negative, you're putting plus, and that goes over the divisor, which was x plus 2. So what's happening here? Why am I harping on you about this? Okay, that does need to be there. We didn't do that before, though. We need to say it and write it. So we need to make sure we do that. So always put a plus sign there between your remainder and that last term of your quotient. Even if it's a negative, just put a negative on the top, and then put your divisor down there on the bottom of the fraction. Okay. So this is the process. We're going through a bunch of examples to kind of show you different things that can happen. So like this gap idea was new. this thing that happened with the 0 was kind of a little hitch. And you really won't see this very much, so I wouldn't worry about that too much, but it just happens sometimes. And again, just focusing on distribution, changing those signs, okay? So you can add, and just being careful with your arithmetic. So yesterday I had my students do this on their own, and then went back and checked with them. So maybe you want to pause it and see if you can do the process on your own, and then come back and watch what I do and make sure things match up. Something to think about. Just kind of a warning first, right? Remember that if there's something missing, we want to put at 0 place. So as we look at our dividend, just noticing it goes to the 4th power, 3rd power, and then it drops to the 1st power. So we're missing something here. So we are missing x squared. So I want to put in plus 0x squared as I write that out. So this would be a time to pause it if you want. See if you can do it on your own. Or check the first step and see if you can get the first step down, and then alleviate a little bit of the anxiety that I'm sure it causes trying to do it on your own. So, or just watch me do the whole thing. So first term to first term. What do I need to multiply x by to get 4x to the 4th, which would be 4x cubed. And I'm going to distribute 4x cubed to x, which would be 4x to the 4th. Noticing that those two are the same, and then 4x cubed times negative 4 would be negative 16x cubed. So I have x to the 4th and x cubed. Things are lining up. I'm going to change that to a negative 4. I'll change this to a positive 16. So again, they do not have to be the same sign. They just need to be the opposite of what they were. So, and then we do the addition. So the first two cancel. Negative 12 plus 16 is positive 4x cubes. I drag down my plus 0x squared. It's my placeholder. And I start the process over. I need 4x cubed. If I have x, I'm going to multiply by positive 4x squared. And 4x squared is going to distribute. It's going to be 4x cubed. And then negative 16x squared. I check to see if I have like terms, cubes, squares, all good. I change my signs, so now this is a negative 4x cubed. This is now a positive 16x squared. Then I add down, first two cancel, 0x squared plus 16x squared is 16x squared. And then I bring down my next term. Start that process over. What do I need to multiply x by to get 16x squared? That would be 16x. Here are these. Again, you guys really shouldn't be drawing those, just need to be doing that mentally. 16x times x would be 16x squared. And then 16x times negative 4 would be negative 64x. Change my signs, negative, positive, add down, negative 48 plus 64 is 16x. Bring down my last term, so this tells me I'm on the last step. This is kind of a long problem. And then go back. So what I need to multiply x by to get 16x, so just be positive 16. Distribute 16x, or 16 times x is 16x, 16 times negative 4 is negative 64. I have like terms. Change my signs. And then negative 62 plus 64 is 2. And there's my remainder. Again, I know that because x cannot be multiplied by anything to get 2. And I had already brought down my last term, so that must be my last step. And so my answer, as my quotient, is 4x cubed plus 4x squared plus 16x plus 16, and then plus, always plus 2 over x minus 4. So hopefully that's what you got if you tried it on your own. Just, again, big things, common mistakes, not distributing. Okay, so like writing 4 here instead of 16. Not changing the signs. Again, it's the second one that usually messes people up. And then just being careless with your arithmetic. So, one was the difference in the degrees of our divisor and our dividend. So this was an x to the fourth. This was an x to, just an x. So there was a difference of 3 degrees there, which actually gives me 4 steps in that problem. Now here, example. So first thing we should do when we start these problems is look for gaps. 4, 3, 2, 0 x's. So I'm missing an x term there. So I'm going to write plus 0x here. And a little trick here. So that one we've seen before, but notice here x squared, and then this one goes to 2, so we're also missing a term here in the divisor, so I hadn't seen that before. So I'm going to also add a plus 0x here. So that can happen, just little things to watch out for. So as I go to write my problem, so I'm going to write x squared plus 0x's plus 2, dividing into x to the fourth plus 2x cubed minus 7x squared plus 0x's and then minus 14. And I remember this morning when I was showing this problem to the students, like, oh, this one's weird long. I get it, there's a lot of stuff we just wrote down. It's actually a smaller problem than the one we just did. If you look back, how I know that is because I have a difference. The degree of the dividend is 4, the degree of the divisor is 2, so we only have a difference of 2 there. So this problem's only going to be 3 steps. So it's actually a shorter problem. There's more distribution we're going to do, but there's actually less iterations, to use that word. So, but we still start on that first term, comparing the first term to the first term. What do I need to multiply x to the fourth, or x squared by to get x to the fourth, which would be x squared. Make sure you distribute everywhere. So x squared times x squared being x to the fourth. X squared times 0x, so that's be 0x cubed. So we really got to not write x cubed, we got to write 0x cubed. So you really got to say that to yourself to emphasize that it's 0x cubed, not just x cubed. So that is different. You can't, putting that there is not okay. And then x squared times 2 would be 2x squareds. So notice how everything lines up. We got x cubed, x squared. So if I hadn't put this here, this x squared term would have been in this place, and then we might have been confused how we're supposed to add these because they don't go together. So by putting that 0 there, it forces that place to be held. So just very visually helpful. Change my signs. That's now minus, that's now minus, that's now minus. And then we add down. So those cancel. 2 plus minus 0, 2 plus 0, whatever, it's still 2. So 2x cubed, negative 7 minus 2 is negative 9x squared, and then I bring down the next term. It's okay to bring down to 0. What it's not okay to have is this to be a 0. That's where things can go a little weird. But it's okay to have a 0 back there. And then I'm going to start that process over. So what I need to multiply x squared by to get 2x cubed, so it'd be plus 2x. I take 2x times x squared, which is 2x cubed, 2x times 0x, so it's 0x squared plus 0x squared, and then 2x times 2, which would be plus 4x. cubes, squares, x's. Everything's in line. Change my signs. And then add down. First two cancel. -9 minus 0, so -9 x squared. 0 minus 4, -4x. And I bring down that last term, which tells me this is the last line of this problem. Let me start that process over. Negative x, or x squared, to get -9x squared, minus 9. Distribute, so -9 times x squared would be -9x squared. -9 times 0 would be 0 x's. And -9 times 2 would be -18. Change the signs. That's now +9. That's now -0. That's now +18. Those cancel. -4 minus 0 is -4. X's. -14 plus 18 is 4. So I already said earlier that was our last line, but we hadn't seen one with an x in it before. How we know we can't go. So what can I multiply x squared by to get 4x? And we can't multiply x squared by anything to get 4x. So that tells us we're done. Another reason we know we're done. So our quotient must be x squared plus 2x minus 9 plus -4x plus 4 over, so our divisor. So I could write x squared plus 0x plus 2. Don't need to. I can just go back to the original divisor of x squared plus 2. Again, this needs to be here. Alright. So that's our last example. Here is the homework assignment. I hope you guys have a good amount of time to get that worked on while you're in class. And of course, I'll be answering questions on Friday and talk to you guys about something called synthetic division, which we really will be using quite a bit as we move through this unit. So Friday's lesson is very important for what we're going to be continuing to do throughout this unit. But this long division, again, works all of the time. Synthetic division is only going to work in certain cases. So we just want to make sure you guys know how to do both. But use synthetic when we can, because it is so much faster, so much nicer. So it starts off really weird, but by the end of it, you'll really like synthetic division. So again, especially in comparison to long division. But I know this is a tough unit or tough section. So feel free to watch problems again, watch examples again, or look up other examples online to maybe hear somebody else talk about it. But I really have tried to narrow things down for you guys in the way that I've seen help students best throughout the years that I've taught this. So hope the rest of your Thursday goes well, and I hope to see you guys on Friday. I really don't imagine I will be gone another day, but fingers crossed. Take care.